All right, guys, I got a lot of positive feedback that you guys liked the video lessons from the last chapter. This is still part of that chapter, so we're going to just talk very quickly about dilations. Dilations are just another transformation on the coordinate plane. Remember, we've talked about translations where you just move something. We had rotations, and we also had reflections. So the last one we're talking about is a dilation. We haven't talked about this one before because the other three preserve congruence, which means that when you translate something or you reflect something or you rotate something, the shapes stay the same size. With a dilation, the shapes are going to be a different size. So in fact, they are either going to be... There we go, still recording. The dilation is either going to shrink or stretch objects, okay? And what determines this is the scale factor. I don't know why, but this variable for scale factor is k. So k will tell us either how large or how small we need to make something, okay? So here's this one. It says, in the graph below, triangle ABC has been dilated to produce ABC prime. So dilated doesn't necessarily mean getting smaller like it does with like your pupils if you go to the eye doctor, okay? Remember, the little tick marks here are called prime, and we call what the resulting dilation is, or whatever the resulting transformation is, it's called the image. Okay, so here we go. We're just going to count these. AC is 1, 2. CB is 1, 2, 3. Now, AC prime is 1, 2, 3, 4, and CB prime is 1, 2, 3, 4, 5, 6. Okay. Now, again, this is review from what we did before, so here, let's just come up with some ratios. In order to find the scale factor, you need to take the image and put it over the pre-image. So the image of AC prime is 4 over 2, and CB is 6 over 3. From this, we can easily say that the scale factor is 2. Since this number is greater than 1, we can say that ABC has been enlarged, or stretched, or whatever. It gets bigger, okay? Go ahead and try this one. I'm just going to write the answers in for you guys as you work. Okay, so you should have gotten that. Okay, here are your basic rules for dilation. The corresponding side lengths. So remember up here when we had like DE and DE prime. Remember, the entire last section was about similar figures. So the corresponding side lengths are going to be proportional. And in order to find the scale factor, you divide a side length of the dilated figure by the corresponding length of the original figure. If the scale factor is greater than 1, the original figure has been enlarged. If k is between 0 and 1, right? So if it just stays the same, I'm sorry, if it's less than 1, no, we don't need to fill this in. It has been shrunk. And if k equals 1, it's literally the same exact figure. So the original figure is not changed. Okay? This stuff right here is just review from what we did in previous sections. I don't need you to do this. If you want to do the problems, you can. And just a very quick few properties about dilations. They do not preserve congruence, which means that when you dilate this triangle, it is not congruent. However, it does preserve the angle measurements. And this one most people tend to forget. Dilations also preserve orientation. What does that mean? It means that if you take this rectangle and dilate it, it will not have switched rotation. So it will not have become, this rectangle doesn't become rotated and dilated. It just becomes dilated. So this does not happen. It just stays going in, like, I guess the same direction, if you want to call it. That's what orientation really is. Okay. Now, when you have numbers on a coordinate plane, it's very easy. You're going to take your original point and you're going to scale it by doing k of x, y. Remember, k is just your scale factor, okay? So 0.09 is dilated from its original scale factor of k equaling 6. All you need to do to figure out the new point, it used to be at 0.9. We're going to dilate it with a scale factor of 6. So I just take 6 and I multiply it times 0.9. And the new point A is located at 0.54. Okay? Same thing, point B, negative 8.5. It's dilated with a scale factor of 1/2. So B prime is equal to negative 4, 2.5. Same thing to the last one, 8, negative 4, dilated with a scale factor of 3/4. So 3/4 times 8 is 6. 3/4 times negative 4 is negative 3. Okay, this should make a little bit more sense once we actually play around with some polygons. So here's one where you have a parallelogram. So let's go ahead and plot the points on the parallelogram. There's A, B, C, and then D. Okay, we're going to dilate this now. So we did this. We're going to dilate this by a scale factor of 1/2. So first, let's find all of the coordinates of these, of the image. So I'm just going to rewrite them over here. A prime, B prime, C prime, D prime. And then I'm going to take half of all of these coordinates. Negative 2, 4, 4, 4, 2, negative 1, negative 4, negative 1. So when I take half of all of these, I would get negative 1, 2, 2, 2, 1, negative 1/2, and negative 2, negative 1/2. So now let's go ahead and plot these points. It should be getting smaller by a scale of 1/2. So here we go. Negative 1, 2, 2, 2, 1, negative 1/2, negative 2, negative 1/2. And here's A prime, B prime, C prime, D prime. Okay, so it's actually as easy as that. As long as you are multiplying correctly and then plotting your points correctly, you should very easily be able to get your dilated images. They can shrink, they can expand. Okay, go ahead, you can do these. I'm not going to walk you through them. I'll put the answers up if you want to keep watching the video. If not, you could just, fast forward through the video and check them as you go. Okay, so for example 3b, you could actually just do this very quickly. I'm just going to sketch out these points, negative 2, 2, 2, 2. So I can see right now I can stop because it's a square. So if I just count 1, 2, 3, 4, I know each side of this original square has to be 4. So if I find the perimeter of this square, it would be 4 times 4, and I would get 16. Now remember, it's scaled by 2. So the next one is going to be negative 4, 4 to 4, 4, which means that the side is also going to be scaled by 2, so it's going to be 8. 8 times 4 is 32. Pay attention because look, the perimeter also gets scaled by 2. So this would be the perimeter of the original. This would be the perimeter of the new one. Snappy.